Well, I have that it's time for us to start. So we should do that since we have don't have that many presentations, but I think there have a fair amount in them. Let's see here. So, oops. This is the Babel Working Group. Donald Eastlake, Fishuay, Russ White, Jennifer is our co-chair, and Martin Vigoro is our AD on the line here. So this is the note well. People have probably seen this before, but basically if you contribute something to the IETF and you're aware of intellectual property like patent rights in what you're contributing, in any form or venue, including speaking or presenting, then you need to declare that. It's a little reminder I give that people should review documents, and it will improve the quality if you do so. So here's the agenda we currently have. Barbara Stark has volunteered to take notes, at least only when she's not speaking, so she has one of the presentations. It'd be good to have a Jabber scribe. I can monitor it to some extent. I don't know how much activity there'll be on it. This is the agenda shown here. Basically some presentation of working group status and the milestone status. So I have some suggestions for some additional milestones. Then Babel, I guess, source specific and IPv4 via IPv6 by Julius. Barbara is going to talk about the Babel information model. And I guess I last couple remaining open questions there. And I have a presentation on Babel as a routing protocol for IEEE 802.11 mesh. It's Wi-Fi mesh. Are there any suggestions for additions or deletions or changes to this agenda? Hearing none, I guess we will go ahead on the basis of this agenda then. So, status, we have published the set of 4 RFCs, the applicability, the base routing protocol, the 2 security RFCs, MAC authentication and datagram DTLS for Babel security. So there are 2 drafts that are through the IESG Shell chat, but need to, let's see, you want to say something, Dave? Go ahead.
So it is 6 a.m. here in San Francisco, so I'm only on coffee, but I just wanted to take a moment and cheers everyone in the working group for publishing these documents. It was a shit ton of work and a lot of arguing with people in positions of power, but we got there. So I want to, in particular, congratulate Julius for making this happen and everyone else involved. Cheers.
I think that's appropriate.
Oh, and speech.
Okay, I don't know. Well, I think Julius may talk about this during his presentation. I don't know. Okay, now I'll go ahead. Thanks for that. Good things to note. So, proceeding on the status, there's 2 drafts through IESG discuss with IESG Telchat, which discusses being resolved, the information model, which Barbara is going to talk about, and source specific, which Julius is going to mention in his slides. There's a publication request for the Yang model, which is I think it's been, the idea is to get the information model nailed down. The Yang model is kind of based on that. Draft in the working group, we have V4 via V6 Julius will also talk about. There's one expired working group draft on the RTT extension, which there's significant interest in, but in terms of using it or something, but there's nothing been done to revive that draft specifically. And in HomeNet, there's the Babel profile, which is still in the RFC editor's queue, basically pending source specific. It was dependent on the routing protocol and source specific. And there was only other draft really presented related to Babel was the beer extension, so it's suggested, which is not currently being pursued, it would appear. So we've actually completed all of the milestones that were originally set for this working group. These typically involved adoption of a draft or submission to the IESG variously for informational or proposed standard. So I think we should really think more about adding some additional milestones into the future, and actually have 3 suggestions. I think the V4 via V6 is pretty well along, and we should be able to submit that pretty soon. There's these suggested milestones and dates. Adoption of Babel multicast draft seems like a good thing, and I have some ideas on that. We can be discussed on there's no presentations on that today, but we discussed on the mailing list, and I can mention how 802.11 mesh does it. And if we're going to do this 802.11, the Babel for 802.11 mesh, we probably need to send a liaison to 802.11 to ask their permission. I talk about that in my slides. Anybody have any particular comments on this? These possible milestones? They say they'll probably come up in later presentations. So.
They all look good to me.
Russ?
Yep.
Okay, well,
they all look good to me. Yeah.
Thanks. Okay, let's see here. So I will. All right. So, Julius, if you'd like to go ahead, I can drive the slides.
So, hello, I'm Julius Krobacek. I think I've met most of the people here. Hello to everyone. And I'm going to tell you just a few words about source specific, and most of my talk is about V4 via V6. Next, please.
Just a sec here.
I'm sorry for the date. It's a copy paste that went wrong.
Okay.
So as Donald said, we've managed to publish 4 documents. So from my point of view, the most important is 8966, which is the revised version of the base specification. If you want to know what changed since 6126, there is an appendix that describes the changes. So the protocol is not strictly compatible with 6126, but it is very easy to adapt for compatibility. The documents are not exactly what we wanted. In particular, there are 2 shoots that are impossible to implement. They were requested by the ASG. So I don't want to give the impression that the ASG behaved badly. Most of the ASG members were extremely helpful, caught quite a few typos, and fixed the documents. They didn't catch all of them, by the way. We had to make a last-minute technical change to MAC authentication in OTS 48, but they were pretty helpful with, I would say, 2 exceptions. And since I don't believe in protecting the guilty, I'm going to mention their names. Alvaro Retana and Mirja Windelkind. And so they said that we need to solve problems that nobody knows how to solve. I tried arguing that nobody knows how to solve and asking the Babel working group to solve them. is too much. So the result is that there are two should in the document that quite simply nobody in the world knows how to implement. There should, we managed to keep them at the should level. So that's an old problem. Okay, it was documented 17 years ago in RFC 3774. Obviously, nothing has been done to solve it. Perhaps some people are interested in keeping it. And we have a number of unpublished documents. So there's information model and Yank, which Barbara is going to speak about. There's source specific and V4 via V6 that I'm going to speak about now, and two documents that we're probably not going to publish as RFCs, which are diversity, one that I forgot to put on the slide, which is RTT. Diversity is probably not useful. I have never managed to build an experiment that showed that diversity is useful. So it sounds like something that's a very good idea, but doesn't help much. And RTT is extremely useful. It's deployed in production, but we don't understand why it works. It's not supposed to work as well as it does, so more research is necessary, and we're not ready to publish it as an RFC. Perhaps as experimental, but I don't know if it's worth it. Next, please. Okay, so just a few words about source specifics. So source specific is a very useful extension to Babel. It allows for a cheap form of multi-homing. It was implemented by myself and Mathieu Boutier back in 2014, and we published it as an equality conference at IFIT Networking back in 2015. Now, the draft, we wrote a draft at the same time as we wrote the paper. And now that we are done with the base specification, we've submitted the draft to ISG, and the ISG was fairly friendly, and I would say too much so, because I've looked at the document after it came back from the ISG. I read it carefully again, and I have found that it's technically correct. I haven't found any mistakes in the document, that it's technically complete. It contains all the required data, but it is perfectly illegible. The problem is that you cannot read. It contains all the information, but you need to read the 2015 paper in order to understand the draft. So I have decided that it's not worthwhile trying to address the individual ISG comments, that what needs to be done is to rewrite it so that it can be made legible. It should not be too difficult because the technical content is there. Make it into a legible document and resubmit. So that is one of my main priorities right now. Next, please. Okay, V4 via V6. So that's something that we implemented this last summer together with Théophile Bastion. So the idea of V4 via V6 is that you don't need IPv4 addresses inside the network. So here I have two IPv4 endhosts, A and Z. They have IPv4 addresses labeled A and Z in red, and they have IPv6 addresses labeled alpha and omega in green. And the idea of V4 via V6 is to avoid having to configure IPv4 addresses inside the network. In fact, if you think about it, the IPv4 addresses of routers inside the network never appear on the wire. The packet goes from A to Z, and the addresses of the intermediate router don't appear. The only reason for which we need IPv4 addresses on the routers is in order to determine MAC addresses using ARP. So the idea here is that you replace ARP with IPv6 neighbor discovery, and everything works. You have no encapsulation, you have native IPv4 packets, and you don't need to configure IPv4 inside the network. Next, please. So what you do is that you configure an IPv6 Babel network, and Blam IPv4 router works out of the box. You don't need to configure intermediate routers. You don't have any encapsulation. You have no translation. You don't have any of the bad features. It looks completely magic. So some people might argue, why are you still working on IPv4? And the reason for that is that we think that doing something like that encourages paradoxically, the IPv4 to IPv6 transition. So right now, there is no good reason to build an IPv6 network. The users are requesting IPv4 because they want to access their favorite IPv4 websites. So if you build an IPv4 network, your users are happy. If you build an IPv6 network, they are unhappy. And here what happens is that just by building an IPv6 network, you get IPv4 for free. So suddenly it becomes worthwhile to build an IPv6 network. Next, please. And so it was implemented by TLC during last spring. It had some testing. I would say not enough, but it was difficult to supervise TLC while in lockdown. And it was presented to the Babel working group as v4 in v6. And here there was an intervention by Margaret Cullen, whom I'm very grateful for. Is she here? No, unfortunately, I don't see her. So first of all, she said the name v4 in v6 implies that there is encapsulation going on, which is why we renamed it to v4 via v6. And she noticed that there is a big technical issue. It breaks ICMP. Next, please. Okay, so my understanding of ICMP is that initially it was a separate protocol from IP. That ICMP was used for debugging networks, for fault isolation. It was not required by the protocols themselves. And then something happened. People decided that network layer fragmentation is a bad idea, and they started using ICMP packet to big messages. They're called something different in IPv4. In IPv4, they're called fragmentation needed messages from the network as part of TCP itself. So what happens here? In this picture, I have a end host on the left, an end host on the right, and the end host on the left is sending data to the end host on the right. Okay, those are the big green packets labeled data. And at the same time, there is a different path that goes from the host on the right to the host on the left that sends X. Okay, and those two paths are essential. If either of those two paths breaks, your TCP connection is going to break. What PMQ discovery does is that it creates a third path in the network. That's the path that I labeled ICMP with the small red packets. And this path doesn't share fate with the others. So if the data path breaks, your TCP connection breaks as expected. If the ACK path breaks, you don't get any ACKs, so your TCP connection is going to time out. On the other hand, if the ICMP path breaks and there is no reason why it should coincide with either of the two other paths, then the ICMP fragmentation required packets are going to fail to reach the sending host, and you're going to have mysterious failures where some things work, then they get stuck. So the problem here is that you have no fate sharing between the data, on the one hand, the data and ACK path, and on the other hand, the ICMP path. So this protocol breaks the main properties of, it breaks the main properties of the end-to-end principle. Next, please. So, okay, I've already said that. Next, please. Okay, so what is the problem? Well, with v4 via v6, we've broken the third path. So the third path starts at a router that is inside the network, and with v4 via v6, this router no longer has an IPv4 address. And an IPv4 address is required in order to send an ICMP packet. So I've given that quite a bit of thought over the last months. So possible solutions include: one, requiring that every router have an IPv4 address; two, cheating by having a single IPv4 address for all routers; defining a way to send ICMP v4 without IPv4 addresses, or do the right thing and give up on ICMP. Next, please. So solution one, put an IPv4 address on each router. So the address need not be assigned to every single interface. You just need one IPv4 address to send your ICMP. That's what the weak host model says, is that you can borrow an address. So in practice, there are two ways of configuring that. There's the Cisco style address where you put the address on the loopback interface, and the Linux style configuration in which you put the address on any one of your interfaces. And when you need to send an ICMP packet, you borrow the address from another interface. So I feel that doing that sort of misses the point of v4 via v6, because suddenly you require manual per router configuration. You cannot just build all of your routers, configure them with IPv6, put them in your network, and have everything work. It's still less bad than you would have otherwise, because you have only one address per router, not one address per interface. So Donald has suggested, but Donald says that he's not sure that he's the one who suggested it originally, so I'm giving credit to Donald here, that this IPv4 address could be drawn randomly, that you could just auto-generate it, use the zero count procedures to do that. Perhaps, I don't know. Next slide, please. Okay, David?
Just on the zero conf addresses, I think you're referring to, I forget the RFC number for IPv4 link local. Oh, wait, I was going to say those aren't routable multiple hops, but as a source address, they might be. I have to go double check that, because you definitely can't use it as a destination across routers, but source might be okay. Anyway,
well, you could use a different prefix. You could use the same procedure with a different prefix. You could use 192, 168, whatever. 10.42.
We can look into the, we can look into this, but I think
all right,
I think they're okay as source addresses.
Yeah, I'll double check, and I can always ask Stuart who wrote that. All right,
I think they're okay as source. Yeah, I think they're okay as source addresses. I don't know.
Cool.
Yeah.
Okay, so am I saturated? Is my audio wrong? Oh, sorry for that. Is my audio better now?
Yes.
Yeah, okay. Okay, so the second solution, and I don't remember whether it was me or David who suggested that, is to do the same thing, but use just one address. So pick your favorite address, say 10.42.42.42, and put it on the loopback interface of all routers. Okay, sounds horrible, but actually the address is only used as the source of ICMP packets. So either you have special handling in the OS or you firewall it away, and you're only allowing it as the source address of ICMP packets. So suddenly you have no per router configuration, you have just the static configuration of the one IPv4 address used for ICMP. Suddenly your ICMP, when you do a trace route, all the routers have the same IPv4 address, so debugging is made more difficult. Okay, we have no experience, I have no experience with doing that, so it's not clear to me whether this fake address should be reserved, okay, as is suggested by D. Who's D?
That's me.
That's you, okay. As is suggested by Donald for the dummy IPv4 address in RFC 7600, which I haven't read yet, it's a big RFC. It's a shared address. Now, shared addresses are used in two cases usually, reusing IPv4 addresses when using NAT or for using Anycast. But this is neither of the two. We're not doing that. We're not using Anycast because we're using it as a source address. I don't know how much experience there is with this kind of things. Next, please. Okay, so the other solution would be to define an ICMP format of ICMP v4 via v6 that allows sending an ICMP v4 packet without having an IPv4 address. I feel that it compounds the problem that I outlined earlier, this third part problem, that the lack of fate sharing Here is going to be even worse because you're going to be mixing IPv4 and IPv6. At any rate, I feel that it's out of scope for this working group. Next, please. And finally, there is what I consider as being the right solution, is that ICMP should not be used as part of the protocol. ICMP should be reserved as a debugging and fault isolation protocol, and TCP should not be relying for it. So there are some solutions that use that. For example, there is an RFC called Packetization Layer Path MTU Discovery, which uses implicit signals from the network instead of the explicit ICMP signals in order to do PMTU discovery. I would prefer something more explicit, perhaps something that is inspired by ECN that does explicit signaling while following the data path and avoiding introducing a third path. So I think that's an interesting direction for research, but it seems to me like it's out of scope for this working group. Next, please. So I've been thinking about what to put in the draft, and what I'm tempted to do right now is to say that every IPv4 router must have at least one IPv4 address, because giving up on ICMPv4 does not seem like a reasonable option in the short term. And saying that sharing a single address between routers is something that we'd really like to do, but we don't have enough experience to recommend it, and use, some weasel wording like more experimentation is needed. I feel that's okay because we're aiming this for an experimental RFC. And as to ICMPv4 via v6 or to avoiding ICMP altogether, only mention it as passing in part of the discussion. And I would like to hear the opinions of the working group on this subject.
David.
So I'm going to propose something that might be heresy. So, feel free to yell at me. It is possible to send an IPv4 packet without having an IPv4 address. In theory, you're not supposed to do that, but at the end of the day, you're just sending bits on a wire. So what I'm saying is, my proposal, I guess, is these routers should support ICMPv4 and should be sending these must support IPv4 and must send these packets for things to work. Saying must have an address, like if they have special case codes to send out this ICMPv4 packet where they use the dummy address as the source, they don't technically have the address on the interface. I guess that I'm kind of totally into semantics here, but I just wanted to ask if there was a distinction that mattered.
Point taken. Perhaps we should describe the behavior rather than thinking about the data structures. So I'm thinking about assigning the address, but the requirement is actually that every IPv4 router must be able to send out an ICMP packet. And it needs something to put in the source field of that packet.
Yeah, and that way I totally agree with you that more experimentation is needed to figure out what goes in there. But saying like you need the ability to send it with something in there sounds like good enough for this document, in my opinion.
Mm-hmm.
Okay, Barbara.
You need to also unmute the microphone, Barbara. You just opened the camera.
Yeah, I just wanted to mention that the RFC 3927, the dynamic configured auto IP addresses, those are those 169 addresses. Those are pretty well universally already supported in most operating systems. Well, universal in most. Yeah, but I know it's in Linux and I know it's in Microsoft, and I'm guessing it's probably in the Apples. So, that should already be there and be easy to experiment with.
Okay.
So I'd like to answer the comment of Russ. Russ, if you do RPF checks, you break Babel. You need to disable RPF. Babel does not guarantee symmetric routing. And so with RPF, you're going to run into trouble just for the data traffic.
Okay, well, we can talk about this on the list and do experiments and things. I think we need to move on to the next presentation by Barbara. So thanks very much, Julius.
Oh, then I guess I don't need to keep trying to mute myself. I don't know.
That's true. There you go.
Oh.
You can go ahead, Barbara. You seem to, maybe you've been disconnected.
I'm back.
Good.
I'm not going to share my video because my laptop is underpowered and apparently that's causing me issues. Okay, so yeah, there's just one thing remaining with the information model that's still a discuss. Next slide, thanks. Can you forward it to the next slide?
Oh, sorry.
Sorry.
Yeah, no.
Okay. Okay, so, and I sent an email about this, and thank you, Toke, for his response that clarified things a little more as to the current state. But there's still discussion about what sort of restrictions, if any, should be placed on the MAC key values. And, you know, this is one that we ran around on twice. And right now we've got this statement about being between 0 and the block size of the underlying hash. And so let's move on to the next slide. And so what Ben Kadek was pointing out, so I mentioned to him some of the discussion about how, you know, OSPF and RFC 2104 differed on how to calculate the cryptographic key from the long authentication key and what was considered long. But Ben said that, in fact, you know, what the language we have won't solve it because I guess the block size is bigger than the L size. And so anyway, or maybe it's the other way around. I get so confused. And so that it won't work. And there was also discussion about conversion of ASCII input, but I think we're fine on the ASCII input. So if we go to the next slide, I think we're fine with just sending the binary, and so that's not a problem. But I think it is maybe concerning that if the requirement we have isn't going to avoid the problem that I think was envisioned, then it's probably not the right requirement. And so I guess, you know, my question is, what is the right requirement? And I think we're fine actually on the Blake 2S with the 32 limit, because Blake very nicely didn't bother trying to create some weird algorithm for rehashing long things so that you end up with the right-sized cryptographic key. And so, you know, for Blake, I think we're fine restricting it to the 32 octets, but on the HMAC SHA-256, I'm kind of curious what others think. So let me open it up. What do y'all think? Help me out here, please.
It's a mess.
That's not helpful.
So the situation is that keys have the block size. People are getting confused between the block size and the digest size. So keys naturally, if I'm getting it right, I'm not a cryptographer, I'm trying to summarize. Keys have, the natural size of keys is the block size. And there are two things that happen. One is that people tend to confuse block size and digest size. And the other thing that happens is that people tend to want the user-friendly feature of having arbitrary size keys, and they develop ad hoc hashing mechanisms, right? Have I summarized the situation correctly, Barbara?
I don't know. I'm also not an expert.
I think,
But I mean,
I think you
oddly,
have.
you know,
My
he is a
opinion,
security AD. He should understand these things. So I can't imagine he's getting confused, but yet.
so my opinion here is no hashing in the information model. Have fixed size keys, even if it's not user-friendly, and say the keys should be coming from something like PBKDF2 or script or whatsoever. They're not user-readable entities. There is no reason to make them arbitrary size.
So they can just be the right size for the algorithm.
Exactly. And now we need to make it sure. That was the bug we had in HMAC. We got it wrong. Automa saved us. In HMAC, we keep getting confused between, we non-cryptographer people keep getting confused between the block size and the digest size, and we must make sure that we get it right.
So I think that I would get even more pushback, you know, given what Ben has been saying, primarily from the perspective. So personally, I view this as a system, you know, that, you know, you've got the management system and you've got all these routers and the whole thing is a system.
I lost your audio. I lost you.
Yeah. She'll probably be back in a minute. It automatically reconnects as she's shown as offline right now, but
Okay.
we wait a sec. There we go. No.
I try this again. I'm guessing I got dropped and nothing I said was heard.
You were dropped for a while, but you're back now, obviously.
Okay, so I think that Ben is going to have an even greater problem with what Julia suggested, primarily because Ben doesn't see this as a system. That is, you know, the management system and all of these routers all together form a system as a whole. He rather thinks of the implementation of the Mac as being standalone somehow, and that it needs to be self-sufficient or something. I'm putting words in his mouth, but so he thinks that nothing should be processing things before it gets to there, and that the implementation of the Mac should be responsible for doing everything, which I think is a really odd thing, because I view this as an entire system and I don't care where in the system certain processing happens. And I think, you know, Julius has made good points as to why you want a lot of the processing to happen in a centralized place and then push out sort of the processed. And what you're proposing is push out the actual cryptographic key to all of the endpoints.
That's actually what I've written in an RFC. I'm not just proposing it. I've actually, now I can say that I've written it in an RFC.
Wait, which so I thought the that the Mac RFC, the Babel Mac, didn't say anything.
Yes, it does. In the
What does-
security considerations part, so here it is, it's 8967. You need to get used to the new numbers. Security considerations.
If I can just say something for a second, if you're doing an information model, I don't see why the information model can't just say this is the binary key. I mean, whatever, you know.
Well, but
It is-
HMAC says
fixed
what is
size.
the recommended input.
Okay,
8967, I cannot find it right now, but we say at one point that the recommended input is a random key, and that if user-readable passphrases are necessary, they should be processed on a central host, and only the resulting hashed keys should be distributed. Okay, so I would feel it's reasonable for the information model to follow the recommendations of 8967.
that seems reasonable. It's the approved proposed standard track RFC.
Okay, and it says, in that case, only the derived keys should be communicated to the routers. The original passphrase itself should be kept on the host used to perform the key generation, e.g. an administrator's secure laptop computer. So that's section 7, the 1, 2, 3, 4, 5th paragraph of the security section 7, paragraph 5.
No? Barbara, are you okay with trying to go with that, and we'll see what happens?
Well, let me ask. So we've also been using the information model as a guide for user interface inputs, which would not be centralized. So do we want to?
Well, I would expect the user to generate a key and then to do a copy paste of the key into a web interface, for example.
Okay, and which paragraph did you say, by the way? I finally brought it up.
5.
It's in the chat.
Oh,
Section 7, 5th paragraph.
okay. Yeah, I would be fine with that. Now, I am going to have to go do battle with Ben again, but I think it's an easier battle for me because my expertise is more in.
Yeah, go ahead.
Go
Dave.
ahead.
So, sorry to interrupt. I pulled up the ISG evaluation record here. And so first off, Ben has already removed his discuss. So no need to battle. We are in the clear, like the document has enough positions to pass. Second thing, Ben said all he wants is, he finds it weird that the information model has a restriction, and he'd be happy with the information model just referencing the other document, which is exactly what we were saying here. How about we just do that and we're done?
Oh,
there's no battle.
Yeah,
for
I
Ben to be
just want to
had.
make sure. Right.
Martin
Okay.
wants to
and
speak, so why don't we go with Martin here? RAD.
Yeah, just a clarification about the status of the draft in the IESG. That document, the number of ballots that document has will drop below the bar in at the end of the week because of AD's leaving. So what I wanted to do is to get that document through before the IETF. And in order to help that, Ben has removed his discuss so that I can approve. But realistically, the discuss is not completely addressed. So I could approve and make sure the document goes through, but the problem is not fully resolved. Or we wait for the problem to be fully resolved, but that will likely bring us after the IETF, and I will need to at least run after a couple of new ADs to get the number of required ballots.
So, Martin, would you be open, and I think that's what you're saying, but would you be open to approving the document today if Barbara promises to address this in the coming week? That way we really reduce the process overhead. I think that would really be worth it in terms of saving everyone's time.
Yeah, so I had made the promise to Ben that I wouldn't approve before the discuss is effectively resolved. So I would have to break my promise, but I can have a chat with Ben, a rapid chat, to make sure that me approving doesn't hurt his feelings, and is okay to continue the discussion even if the document is approved.
Yeah. Or
And-
I
and
have
I-
another. Go ahead, Barbara.
I was just going to say, yeah, it's my understanding that I needed to get this, ironed out with Ben, and so that's my intention.
So
Okay.
Another proposal could be, Barbara, you just remove that recommendation, because removing text is always easier than adding text. Like, you do that today, you submit a new version of the draft, and then tomorrow Martin can approve it, and that way Ben's happy, Martin's happy, the working group is happy, we're all happy, we can have more drinks. How does that sound?
I think that's problematic. I think that there needs to be some restriction on the input, because it's too loosey-goosey as it currently is, and that's going to lead to configuration issues and problems.
Okay,
So
so what does
I'll
Ben
iron-
want? Can you summarize again what Ben wants?
So
Can you summarize what Ben wants?
And let's see if it's acceptable. Let's try to be productive here and see whether we cringe or whether we whether we find it acceptable.
I just pasted Ben's comment into the chat in case that's helpful.
okay, so I think my audio is reconnected again.
Yes.
So I'll iron this out with Ben today. I'll try and now that I've got more information and better information, I think I have a path forward that I can work with Ben, because he also said that some of what he wanted was, if you have justification for the recommendations, you can provide that, and that'll make it easier. But right now it's not understood why there are restrictions. And so I think I can come up with maybe some text about why there are restrictions and what the restrictions are, and I can point to the RFC 8967 to help me with that. So I think I can work it out.
But
Right.
wait, the key size for SHA-256 is at most 64 bytes. If you have something longer, you need to hash it first.
I think
Okay.
it's 32 bytes, but we can work this out.
So I don't understand Ben's comment here.
Well, maybe we should take the rest of this offline.
Yeah.
Well, there was the OSPF. The OSPF said you only needed to have your key of length L, which was the 32. And so that's where the OSPF was causing issues, because some of, the code was trying to reference OSPF. And those were the closed issues. Okay, so I think I've got some information. I'll try and get it.
Okay, do you want to say anything about the last slide you have here?
Those are the closed issues.
Yeah. Okay. That would be this one. Oops. Let's see. second. Okay, so I'm going to go through this presentation pretty quickly. You can examine the slides at your leisure and have a little less time than I'd planned. So I chaired the 802.11 mesh task group for part of its existence. But I probably don't remember everything because it was a while ago. The 802.11 standard is pretty big. You can download it yourself and peruse all 4,377 pages of the 2020 version if you wish. And I'm speaking entirely for myself personally here. So talk a little bit about the background of 802.11 and mesh. A fair amount of information about existing Wi-Fi mesh, so you can sort of see how it's a big framework that Babel routing protocol could fit into, and a little bit about process and stuff. So Babel does very well at handling networks with links that have unstable metrics, like radio links, and that's what a Wi-Fi mesh is. So it seems only natural to consider using the Babel routing for Wi-Fi mesh. So you get a lot of stuff with fused Wi-Fi. It knows lots about adjusting and negotiating data rates, and for fancy versions, it can do beamforming. It can switch between different channels. It knows about different spectra in different nations and stuff. And although the normal frequencies used are license exempt and unlicensed, there are frequencies you can use Wi-Fi protocols in that have various licensing regimes, and that's all in the standard. It has lots of things to do with aggregation, so you can get really high data rates, because acquiring the channel, acquiring the air interface is considered expensive. So if you're doing a high bit rate, then once you acquire it, you want to pump a whole bunch of bits through. On the other hand, there can be very slow, noisy channels and things like that, and you don't want to send things for too long because you'll get errors, and so there's fragmentation features. To improve reliability, it has a link level, one-hop acknowledgement and retransmission, and has like counters and things to avoid getting duplicates due to that. You can defeat that if you want, turn a bit on the header. It has the security, the encryption and authentication it has is essentially almost always built into the hardware or firmware in the chipsets, because everybody assumes that almost everybody is always going to want to secure their radio links. So it doesn't, you have to set up the keys, but it doesn't cost you anything in terms of data rate or anything to use encryption. And since there's billions, literally billions of chipsets shipped annually, the cost of making the protocol more sophisticated and putting in these fancy features can be amortized over a huge number of chips. And if you're interested, the goal for Wi-Fi was always 100 meters for its range, opposed to 10 meters for Bluetooth. And lastly, 802.11 believes in a single unified complex header. Rather than trying to sort of nest headers, it just puts more stuff and flags and options in this one unified header, which is kind of an interesting approach. So 802.11 mesh was originally designed just to provide wireless backhaul for access points. There's the schedule. It's all been rolled into the current standard. There's a list of some implementations. I don't know if it's complete in Wikipedia. So here's a typical bunch of access points and stations for 802.11 extended service set, it's called technically. And there's usually, it's an SSID, service set identifier, which identifies this. And the idea with the original version of mesh was just to be able to have mesh links between the access points and have access points that were not connected to with their wireless infrastructure. So about 802.11 mesh, the links are obviously they're peer-to-peer. Every mesh station in an 802.11 mesh has a profile, and they don't peer unless the profile is the same. Includes a mesh ID, a path selection protocol identifier, a path selection metric identifier, and congestion, synchronization, and authentication protocols. And if you have authentication turned on, they won't peer until they've authenticated each other to a pair of stations that are trying to peer. They discover each other through the beacons that 802.11 stations normally transmit, or you can also do probe requests and probe responses. And the beacons and the probe responses contain a mesh configuration, which includes the path selection protocol and the path selection metric. And you can put FF there, and then you need to include another information element that gives the vendor identified by an OUI and the particular vendor information. So the SSID is not used. There's always an SSID field there, which is set to the wildcard value. I think it's just a single asterisk. but there is a mesh ID element, which is the same as an SSID. SSIDs are almost always readable, but in fact, technically, it's just a 0 to 32 octet binary string. I don't know how 802.11 user interfaces work very well if you use an unprintable SSID, but that's how it is. So 802.11 mesh, from an external point of view, it looks like it's a single multi-access link. There's a bunch of concepts I don't want to go into all the details of, including the mesh gates and portals and distribution system, but generally you can hook to the outside world, of course. And you can have a mesh point which is also an access point. A particular device in one box can obviously be an access point and or mesh station and a mesh gate and portal all co-located. So you can have a mesh, 802.11 mesh in the middle, and they have it used to connect two wired local area networks, for example, like this. So in 802.11 mesh, it's an 802 thing. 802 is MAC kind of place. So its routing is based on MAC addresses. And in the most general form, a data unicast frame in the 802.11 mesh has 6 MAC addresses in the header. Told you it has a unified complex header. There's the transmitter and receiver in the radio link. There's the mesh source and mesh destination, and that might be it if it was coming from a node in the mesh to a node in the mesh. But if it's coming from outside the mesh and destined outside the mesh, then you also have the original source and the final destination MAC address. Of course, these could be like IP routers that were, just right outside the mesh or something like that. They have a TTL, and they have a 4-octet mesh sequence number. So duplicates of the same mesh source and sequence number are dropped. So basically the way multicast and broadcast works in 802.11 mesh is it just sort of floods it, and the mesh stations are required to keep a cache of recently seen mesh sources and sequence numbers and drop duplicates. So the default path selection is this hybrid wireless mesh protocol. It has a on-demand ad hoc mode, which is very similar to AODV. It doesn't actually reference RFC 30. Well, there's a reference, but you don't need to look at RFC 3561. The specification in the 802.11 standard is entirely complete. You can fully implement it without looking at the RFC, but it is based on the idea of the RFC. And there's also a tree building mode. If you declare a route or more than one route, you can build a tree. So you can have things like you can always get a packet from a frame from one station to another by going up to the tree root and back down again, even if they're in different branches or maybe a smaller portion of the tree. But you can start doing that, and then you can use the ad hoc on-demand stuff to try to find a more efficient direct route between the two stations. There is a metric. This is the default metric used, and actually the metric and routing protocol I give here are the only ones that are actually specified in the 802.11 standard. It's called the airtime metric, and basically it's the overhead plus the number of bits in your test frame, which they recommend you calculate this using a 1K octet frame, the data rate and the error rate. So if I have a 50% error rate, you assume it takes twice as long. It's the average, you'd have to retransmit it, and that enough to cause it to take twice as much time. So if you ever have to do a presentation to 802.11, as a hint, it's good to include an equation in your presentation. 802.11 likes equations, so there's one. So there's some other stuff about it. The 802.11 quality of service features are theoretically optional, which they basically allow higher priority data packets to be given preference in acquiring a radio channel. There's all a bunch of really detailed timing which controls that. The 802.11 mesh has its own power save stuff. You can have peering can be in active light sleep or deep sleep modes. Turns out every time they adds a new major feature to 802.11, they have their own ideas on how to improve battery life and do power save and stuff. Obviously, this is only if they sufficiently low level of traffic. It's got a beacon collision avoidance feature to avoid collisions due to hidden nodes where one node can't see another for some reason, congestion avoidance. You can have a channel switching. You can switch the whole mesh from one radio channel to another. So it's the way the mesh is defined. It's kind of assumes a single radio per station, which isn't really an effective way of doing mesh. But really, people extend that and almost always have multiple radios. And there's even emergency services support for certain applications in certain areas. Somebody might attempt to be making a voice call to an emergency number. You have to allow them to do that legally. So when you do a peering open, you can say, I need emergency service, and it has to let you in, but it may restrict your bandwidth and only route you to an emergency service access point. So I'm going to go on a little over here, and this is not a problem with people. So we could specify Babel routing as an 802.11 mesh path selection protocol. And you probably need to add a Babel address encoding for MAC addresses to do that. And additionally, we could specify the 802.11 mesh link metric based on ETX, for example. And I think I only have one more slide here. Yeah. So I'll just give this to Julius. So although 802.11 mesh is clearly designed to be extensible in this fashion, and you can even vendors can extend it without even talking to 802.11 by using their using this vendor extension feature. Nevertheless, experience indicates to me that the IESG and IETF will want a explicit liaison from 802.11 saying it's fine for us to do this. I don't believe that will be hard to get. And in fact, having that might be useful because it's possible, although theoretically we only need a path selection protocol identifier and possibly a path selection metric identifier, we might want other numbers from their equivalent of IANA. The 802.11 working group has its own equivalent of IANA. And it's possible there might need to be a mesh, a charter update for this. So Julia is here first on the list. Go ahead.
Yes, so I have 2 points. So first, there is a lot of the complexity in Babel is due to the requirement of having the same IP address at 2 places that don't have synchronized sequence numbers. Okay, so think about a default route. You can announce a default route at 2 points in a Babel network, and the 2 routers that announce the default route don't need to have synchronized sequence numbers. Now, if you're working at layer 2, you no longer have this problem. Because a given MAC address you announce at only 1 place in your mesh, right? Means that a lot of
you would hope so, but you can have in the real world, of course, you can always have more than one device that claims to have the same MAC address.
Oh yeah, but that's not normal. That's not the normal behavior. While in the case of an IP network, having the same IP prefix announced at 2 places is completely natural, and we don't want to have synchronized sequence numbers. Sequence numbers are not clocks, they're not synchronized. So if you do Babel at layer 2, then it becomes much simpler. So that leads to the point. So that leads to the point that if you do Babel at layer 2, you don't want to use Babel. You want to use the simplified protocol that no longer needs to carry router IDs. So the distinction between IP prefix and router ID is due exactly to this problem. But once you're working with MAC addresses, you can give up on the router IDs and use the MAC addresses both as the prefix, both as the destination of traffic, and as the router ID. The second point I'd like to make is that when 11S was originally defined, I haven't looked at 11S in ages, but when I looked at it many years ago, it actually had 2 routing protocols. One which was a must implement, which was
the other was kind of a link state-ish kind of thing, OLSR, I think, and it basically there's tremendous pressure in 802.11, in IEEE working 802 working groups to simplify things. And basically, although a lot of work was put into specifying that, it was removed. So the final version has only HWMP.
Okay, so I had the impression that the OLSR-based routing protocol nobody ever implemented.
I believe that's, well, there may have been some experimental, but there's certainly nobody ever, it never got out of a laboratory.
So why do you think that an optional Babel-based protocol wouldn't suffer the same fate?
Well, I think Babel would be could easily be better than HWMP. So I don't know. Do you believe that there's only one ecological niche or something? I think that that Babel, basically a distance vector with the additional features Babel has to avoid problems with the naive distance vector would be a good option for 802.11 mesh.
So I think that Babel is better than OLSR for a simple reason is that when I designed Babel, I knew OLSR, so I could learn from them.
Yes.
And but the question is there actually a market demand for another routing protocol in 11s?
That's an interesting question.
I don't see the argument that would lead the 11s community to be. I don't know the 11s community. It's a question.
I'm not sure there's a single unified community. I think it's a little diverse. So unfortunately, we're over time at this point.
Sure.
So Dave, go ahead.
A very short question related to what Julius was asking. I think in this working group, we've had a implementation first mindset, which has been incredibly successful. Do you have people lined up who would be implementing this?
Not right now, but I'm not proposing I don't think a particularly rapid timeline on this. I'm thinking that we would maybe issue a liaison to 802 from the next IETF meeting if we think between now and then we've satisfied ourselves that that's a useful thing to go ahead and take that step. So I just wanted to give people background so they think about it, and I think we can work on finding people who would implement it and so forth.
Cool, thanks. Yeah, my general take is extending a liaison to tell people like, hey, we have this option if you're interested, sounds good. But my personal opinion would be that we shouldn't recharter to take this work on unless we have specific implementers on board first.
Okay. Any other comments on this or anything else? Since we're substantially over time, thanks people who stayed, and I can see you on the mailing list and at the next IETF.
Bye, everyone. Good to see you.
Yeah.